back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Alameda International High School. And in this video, we're going to start with some review, but we're going to be working on writing some trig functions. So we're going to be going from the graph to the equation. And so some nice little review for us. When x equals 0 degrees, where does the function y equals sine of x start at? So it starts at y equals 0. So make sure when x equals 0, we can say y equals 0. And we're saying, again, looking at the x value, when x is 0, what is our y value? It's also 0. However, when x equals 0 for cosine, we're going to say it starts at 1. So again, when x is 0, what is our y value? That's going to be 1. So that's going to be the key difference between these two functions. Again, sine starts at 0, cosine starts at y equals 1. Make sure you can also remember this. You can say the start and end point will be the same for one rotation. And when I'm talking about one rotation, I'm saying for one period, meaning the period for these two examples is 360. That means B is 1 because we have one peak. And so we're saying, hey, the start and end point for sine is 0, and the start and end point for one rotation of cosine is 1. So make sure you're seeing those for yourself. Also too, underneath that some review, we can say we have this. Let me try to fix this just a little bit. Something like that maybe. Hopefully it doesn't fall. Okay, so some review for us. We're gonna say, all right, sine function kind of looks like this. It has y equals a times the sine of b times x, and then we're gonna have y equals a times cosine of b times x. And what do those letters stand for? So we're going to say this. We're going to say, well, we're going to have A and B for those two, but make sure you understand what those mean. So we're going to say the amplitude is going to be the height. So this should be reviewed, but we're going to say the height of the function. And when I'm saying the height of our function, I'm talking about the curve, the colored curve, the line of our function. I'm not talking about the window. So make sure you're saying it's the height of the function, again, not the window. All right. A way to find that, usually don't use this one, but you can have it just in case. So we're going to say the absolute value of the max minus the min divided by 2, or you can just say the absolute value of A is going to be our amplitude. And so the constant in the equation for that is going to be A for amplitude. So a real simple one to remember. For period, however, it kind of uses a combination of things. We're going to say the period is going to be the length. The length. Actually, let me also for amplitude, let's say think y-axis for amplitude, and then for period, think x-axis. Maybe that will help some people as well. All right, so we're going to say the length of the function, the length of the pattern or the cycle of our function. All right, of the function. So, how do we get that? Well, gotta be careful. We're gonna take 360, so 360 divided by b. That's gonna be how we find our period. So this equals period. However, again, what is b? Again, it's referring to that coefficient of the variable x in our equation of our function. And again, if you look at that letter b, that value of b, that constant, we're going to say that's going to be our number of peaks from 0 degrees to 360 degrees. Again, the reason why we have that is because that's the adjustment from a normal function like this. So notice how, again, we don't count the first one because we're saying, hey, we go down and then back up to our one peak. And so this is why our value of B is 1, which is why that period was 360. So find period using B. All right. So some new stuff. So again, this is going to be new to you guys, but we can use the resources that we've had before. So we're going to say, all right, these are going to be the steps to write a trig function from a graph. So first step, determine if it is sine or cosine. How do we figure that out? Well, when x equals 0, sine of 0 is going to be 1, cosine of 0 is going to be 1. So when x equals 0, y equals 0 for sine. When x equals 0, cosine of 0 is 1. Okay, so determine using that picture. Then we're going to write down our amplitude. Again, that is our value of A. Then we can find, step 3, find B using period. So again, using period or the number of peaks. So make sure you can use either one. So you can say, hey, if it goes from 0 to 360, then I can count the number of peaks, or I have to find that period. So remember, that's when it repeats itself. So how many degrees on the x-axis does it go, from left to right? How many degrees does it go for one rotation? And you'll see some examples here in a second. And when I say the last step, it's just going to write the function. And when I say write the function, I'm talking about the equation. Again, it would look something like this. We're going to say y equals a times sine of bx, or y equals a times cosine of bx. So that's what those steps are for here. All right, in that first example, we can say this. We're noticing, okay, what's going to be our first step? Is it cosine or sine? Well, does it start at 0? It does not, so does not start at 0, so therefore we're going to say it's going to be cosine. Sorry, step 1, cosine. Step 2, what's the amplitude? So what does it go up to? So it goes up to 4, and it goes down to -4, so that means A is going to be equal to 4. A is going to be equal to 4. Then we can say, all right, what's B? Well, does our window go from 0 to 360? It does, so we can count the number of peaks. So we're going to say, all right, we have 1, 2, 3 peaks. You can also look at the min. How many times does it hit the min? It goes 1, 2, 3 times. So again, this is the number of peaks from 0 to 360. So we have B is going to be equal to 3. That means our period would be 120. So if you look, if I go down and then up, I have a full rotation from 0 to 120. So that checks out. Then we can write our function. We're going to say y equals, I have 4 cosine of 3x. And real simple. And then let me actually have one last step. So remember to check using your technology, which I mean your calculator. All right, because I want to make sure that it looks just like it should. All right, so I have, let's see, my window, I go 0 to 360. However, it counts by 30s, and it goes from -6 to +6, and it counts by 1s. Okay. If I want to, what I can do is if I want a red line like the picture has, that's totally fine. I can go down to y2 because that has red. Again, in different colors, same idea. So let's type it in. I have 4 and then cosine. Make sure it's in here. 4 cosine. And I can say 3x. Hit graph. Let's kind of see what it looks like. So it starts at the top, goes down up to +4, and then it cycles through. Notice how many peaks we have. 1, 2, 3. Again, if I need to check those values, I certainly can. But again, we're going from the graph to the equation. All right. Clear. Flip back over. All right, so we got some your returns. Make sure you can try those out for yourself. But I'll give you one more example. So in example number 2, it has this picture. So be able to say, okay, well, I did start. So starts at y equals 0. So that we're going to say it's going to be a sine function. Okay. Notice how, again, when x equals 0, what is our y value? It is also 0. So it starts, or it is sine function. What is our amplitude A? Well, it goes up to 1, down to -1, so it's going to be just 1. We're going to have B is what? Well, we go out to 360, so how many peaks do we have? We have 1, 2, 3 peaks, so B is going to be equal to 3. We can say y equals, let's have 1 sine of 3x. You could also just say this is y equals sine of 3x. Again, that 1 is just in there as a coefficient. You don't have to have it there, but as long as you understand that it is there, we are good. If it was a -1, you'd have to put a negative sign, but just make sure you have it in there. And I'm going to do that last step. Let's have y equals sine of 3x. Hit that graph button. Again, notice how it's, since the amplitude is 1, we have a shorter function, meaning on the y-axis we have shorted, but from 0 to 360 we have 3 peaks, which is why we have b equals 3. All right, figure that out. For that next turn, your turn, real simple, try it out for yourself, double check with me when you're in class. All right, moving on to that third example. So for number 3, it says, again, make sure you can pause for yourself. Try this out. Again, this is your turn. All right, picking back up, we're going to say for example number 3, it does not start at y equals 0. So therefore, it's going to be cosine. So we're going to say this one is going to be cosine function. Let's figure out how tall it is. So we're going to say our amplitude is 2. Notice how it goes up to 2, down to -2. For B, this is a little trickier. Several people wanted to say, hey, how many peaks do I have? Well, that's not the case because we have to go from 0 to 360. So make sure you're only using those peaks when we're saying 360. So let's use a period instead. So what is our period? Well, I'm saying from 0 to 90 is one entire rotation. Again, start and end point. I have my 2 zeros and I have the min. So I'm going to say my period is going to be 90, which, how do I get that? Well, I'd have to have 360 divided by 4. So that means that B is going to be equal to 4. Again, notice there's not 4 peaks here because we're talking about peaks from 0 to 360, which our window does not have. But we can check using that calculator as well. All right, so again, we have our values. Let's write our function. So we have y equals, and we have 2 cosine of 4x. And be careful on this one. A lot of people mess it up. They wanted to say this is b, which it is not the case. We're saying from 0 to 90 is one rotation. Again, it goes from the start to the end point. Then we have our full rotation. From 0 to 360, we would have 4 peaks. right. Be sure to pause, try out the your turn for yourself. Again, see what, if it starts at 0 or not. Find the amplitude, find the value of b, and write your function. All right, 2 last examples. Let's try it out like this. All right, so it gives you now, we're going from the words to the equation to the picture. So a couple steps here. So it says a sine function that has an amplitude of 4 and a period of 180. So we're going to say this a is going to be 4. Be careful, we're not going to say b is 180. We're going to say b is equal to 2. And how do we get that? Well, I can write on the side, I would say, also too, if you need to see how I did this one, let me double check. I would say 360 is equal to, or sorry, 360 divided by b is equal to 90. I'd have to say, hey, what number divides 360 to get 90? So 360 divided by 4, I would say this is 4 is equal to 90. Similar idea, I'm saying 360 divided by, I'm saying 2, gives me my period of 180. So again, notice how I'm going from the phrase period to my value of b. Again, these are 2 different numbers, so make sure you're careful on that. All right, so I have my 2 constants. I have what my function is going to be. So I'm going to say y equals, and then I can say I have 4 sine, and then of 2x. And what I can do is I can kind of write those, I can make a little table for ourselves, that way it's a little bit cleaner. I have x and I have y, so that means this. I can take, if I need to figure out what my first 5 values are going to be, I can take my period, which is 180, and divide it by 4 to get my values, or my change in my x. So every 45 degrees, I'm going to have a nice clean y value. So when my change in x is going to be 45. So I mean this, I have 0, 45, 90, 135, and 180. Okay, so notice I have my list of x values. What are going to be my y values? Well, I know that my start and end point have to be the same. Again, my start and end point have to be the same. We said sine starts at 0, so that means it ends at 0. Also too, I have to hit the minimum, so I'm going to be, so I have to hit the max, I have to hit the min, and I have to have one more 0. So it starts at 0, it goes up to 4, then it would go down to 0, and then it goes down to -4 and back to 0. And so let's kind of plot these out, and then we'll kind of see what those look like. So I have 0, 0, I have 45, 4, I have 90, 0, I have 135, -4, sorry, one more down, and then I go to 180 is 0. So notice how I have one rotation from 0 to 180, and then I repeat myself. So now I can go 135, or sorry, 225. It was 225, 270, 315, and then 360. So how many peaks from 0 to 360 did we have? We have 2, which is why our value of b is 2. Again, I can check using that wonderful little technology. So I hit, let's have window, let's do our change in x is 45, our max, or maximum are 4, and I can have that function. So let's have y equals 4 sine of 2x, hit graph, and let's kind of see what it looks like. So it goes up, hits at 180, and then it repeats itself. So notice how it has those 2 peaks, and we know we're good. Again, be careful on the your turn. I'll actually help you out and read it for you first. So it says a cosine function that has a period of 90 and an amplitude of -3. So I'll help you out with that because a lot of people are going to make a mistake. Try it out for yourself first, but I'm going to start you out with this table. Since I know my period is 90, I'm going to take 90 divided by 4 to get my change in my x values. So I can have 0, 22.5, 45, 67.5, and 90. So those are going to be my 5 x values that I have for one rotation. So try these out. Again, notice how it has amplitude as -3, so that means you start and end at -3. Try that one out, check with me to make sure you are correct. And then lastly, last example, and you'll have your turn. It says a cosine function that has an amplitude of 1/4. So I can say A is going to be the same as 1/4, which is 0.25. And then the period is 720. So this is a little bit trickier because I'm going to think, well, wouldn't my period be 2, or my value of B be 2? It's not the case. So I'm saying, what value of B would make this true? Well, I could have B equals 0.5. That's the same as dividing by 1/2. So I'd say 360 divided by 0.5 would give you 720. So now I can have, let me write my function down here. I can say y equals, I'm going to have 0.25, and I have cosine of 0.5x. Let me make my table. I have my x and I have my y. So I'm going to have my 5 values. So I have 0, 180, 360, 540, and 720. Again, be careful in this. Notice how our window only goes to 360, so we're not going to have a full rotation in our window, but that's okay. We're still trying to work with what we're given with, or work with what we have. All right, so I'm going to have this. I'm going to have, all right, cosine. That means it's going to start at R max and end at R max. So we have 0.25. We're going to have the min in the middle, so we're at 0.25. And then we have our 2 zeros. Again, make sure you're saying I can only plot these 3 points since our window is like that. Again, it's going to be real tight since we just have a very short graph. So we have about 0, when x equals 0, our y value is 0.25. When x equals 180, our y value is 0. And when x equals 360, our y value is negative 0.25. Okay, make sure you can try those out for yourself. Let me actually graph this one using the calculator. And I also have to change that window so that way it looks a little bit better. So 0.5x. I'm going to go out to, let's say, 720. That way you get a full rotation. Hit graph. Notice how it's really close to that graph, or that, excuse me, that y equals 0, since it's really close. I can make it bigger so that way it's easier to see. So notice how it goes 0.25 and then back up to 0.25. Again, that's from 0 to 720, it has 1 peak. Again, make sure you can try your turn out for yourself. Double check with me, double check with your calculator, and as always, super slam that subscribe button.